Let me briefly introduce myself for those who are for the first time here, and especially for our Georgian colleagues. I'm an architect and urban designer. I'm practicing already for a couple of decades in Lithuania, in Vilnius mostly, and in other cities. I'm also teaching at Vilnius Gediminas Technical University Department of Urban Design. Well, I'm also researching in different types of European projects. In this particular case, we have Framework 7 project, and our current current research field is green building and sustainable urbanism. So let me share some ideas with you. I will touch several aspects about the topic which I'm presenting today. Maybe I hope it will be a little bit more like a workshop, as we called it. So I will leave some time for your questions and possible discussions. I will look through what we mean by green buildings, and then I will comment a little bit on very interesting and very efficient approach in design, in architectural design, and in engineering, which has a very interesting name, bioclimatic. And then we will review some case studies, some projects that were designed and executed in some countries, and I will say some words about Lithuanian Green Building Council, expecting that you also have similar parallel activities in Georgia. Let me start with this fancy picture, which I got from internet. As you know, a couple of days ago, the airplane was launched, which started its round-world trip on the 30th of May, and here you can see the map on the left corner of the slide. So, if this type of machine is going to fly around the world without any additional energy, without any fuel, isn't that a shocking news? We, for example, we flew into Tbilisi using airplane, a huge machine, which of course was not flying on sun energy. It was consuming several tons of aviation fuel and then discharging plenty of CO2 and other emissions. So I thought, if this type of groundbreaking changes take part nowadays, maybe we should also consider all types of activities that we are doing, different types, different fields of our activities, from architecture into engineering, and then going into very sophisticated fields of our activities. Well, probably we will not set the building on wings flying around the world, but isn't that an opportunity, a great opportunity to reconsider many things that we're doing recently, and sometimes we're not very happy with the results and the outcomes. Well, the phrase green building sounds very innovative, but indeed it is a well-forgotten past. I'm intentionally omitting the slides with our vernacular buildings, which are 100% sustainable in terms of materials, in terms of mobility issues, in terms of energy also. And I'm starting with quite recent and quite modern ideas starting from the end of 19th century, beginning of the 20th century, where utopian ideas were created of people aiming to make our cities more livable, more healthy, less suffering from congestion, and more attractive for people to live in. So probably you know these ideas quite well, and just I'm always impressed with the slide which is on the right side, which is showing the yesterday, which was nice and green all around, and today is smoky, you have factories and the congested skyline, and then tomorrow is again prosperous. But if you notice, the element which is adding from the second picture to the third at the bottom is landscape. It's not devices. It's not heat exchangers. It's not CHPs, but it's landscape. So probably reconsidering our behavior with natural environment is one of the possible ways towards better living. And then I have another phrase by one American researcher, who said, what's in his opinion is green urbanism. You can read this phrase. It's the practice of creating communities mutually beneficial to humans and the environment. There's no word about buildings, there's no word about transport, no word about infrastructure here. So he's describing green urbanism as something special, like the practice of, there are three critical words which I have underlined. It's communities, humans, and environment. Then let's have a look on a couple of slides which look very organic. I hope you can see them quite well. Two pictures which are imitating or they are replicating natural shapes and natural forms. The one is a city in Netherlands and the other is a well-known design project in Dubai, UIA. Well, even though the form is similar, but probably you know that the town in the Netherlands has installed a smart grid system and it's saving around 70% of energy, which is used for heating and household needs and for industry as well. And the project on the right side has enormous costs and enormous energy spendings. As for keeping this natural shape and as making all the thing run like it is designed. So sometimes just the external appearance and the fashion of design says not so much. We have to look deeper into the content of the thing. This line depicts the traditional or conventional design process what we have been doing for ages. Starting with a developer who is giving a task to a designer. The designer makes the design, selects the material, gives it over to the person who is building the thing, or to the company. And company, when they complete, they give the keys to the user. And then the user, when he needs some service, he goes to the maintenance company. So this is a linear process, which we used for many decades. And it seems very fluent and very logical, but the shortage of the system is that at the beginning we have raw, the materials that we obtain, then we have the product, which is the building, and then at the end we have the waste. So what we do with this process, we turn the raw into the waste. And then I should also put the question mark, where shall we put the waste? What shall we do with it? Instead of that, while having noticed these shortages, an integrated process has developed where different stakeholders like real estate developer, designer, material provider, construction company, maintenance company, and the one who gives money for all that is working in a team. It's a sort of a secular process where actually we cannot figure out what is the waste of this process, but still there is some waste, and then the waste of one cycle becomes the raw of another cycle, and then the whole process just goes on. So it is a secular process which is moving around, and this is something how to access green building. If we look a bit on design methods, so related to the different processes, linear and secular processes, we also have these different methods that our human practice has gone through. So if we focus on pre-modern methods that were mostly based on craftsmanship, the thing that has almost vanished nowadays. We can make beautiful drawings, but give me the masters who can make a roof structure without a nail, and people who can construct the buildings as they were built 100 or even 50 years ago. We don't have such masters, at least in Lithuania we have difficulty to find such people. Then modern methods which were based on a machine, we can call them Fordist methods, when the whole process was moving like a conveyor. Then the next phase, when we learned that this machine-based method does not work so much because our life is more secular. It's not going like a conveyor. There is no beginning and no end. It's always rotating and moving. Lean design was a sort of invented, like an introduced process, and it was more knowledge-based, less hierarchy, and less demarcated, involving different stakeholders and different professionals. Well, relatively more current phase of development in design and construction we can call knowledge-based planning to some extent, where we put a special emphasis on public involvement, on activities like IT-based activities, when we simulate the results of the project before they are actually built, to be able to learn about possible problems before they are realized and before resources are invested. Just a fast comparison of process layout, how it looks in a mass production of Fordist design and flexible design scheme. The interesting thing is that, for example, if you take the first bullet point, the team starting small and then expanding in mass production team works completely opposite in an opposite way in a flexible design team. When the team starts large, when everyone is involved. You remember my previous slide with all the stakeholders? Everyone is at the beginning here. Everyone is working with the concept and says his word. And then, during the process, as long as the tasks are solved, it can become smaller and contract. So there are evident differences in the way how we should organize our work, our process and our cooperation between the professionals that take part in creating buildings and cities. Well, this is a theory created by one person, Christopher Alexander, who knows the name of Christopher Alexander. First he was a very famous professor in mathematics, and then he turned into urban philosopher and theoretician in architecture and urban design. And he figured out that creating a city, well, he was saying that there is nothing more complicated like creating an urban structure. And there was a remark of one former cosmonaut who said that it's earlier to fly people to the moon than to create a livable urban environment for communities. So Christopher Alexander figured out 4 layers of patterns that actually could be discovered and that could be used while creating urban environment. If I would start from the bottom, the existing urban structure is just the quaternary pattern. It is not just the number 1, 2, 3, 4. It's also the order. So the beginning is the primary patterns are all natural things. The secondary patterns are all our legacy and heritage elements, like another layer which comes on the territory. The tertiary pattern is not the buildings, it's not infrastructure yet. It's culture, cultural diversity and cultural atmosphere, which sits like additional layer on the territory. And only in the last point we design and we make our urban structures. What happens usually, also in many design schools, we start with quaternary pattern, and then we complain about the bad result that the thing is not working, because we clearly forget the 3 first layers. If we come closer now to the topic of our theme today, so green building could be described by all these nice phrases, all these nice meanings that you can read on the slide. But still, of course, nowadays we speak most of all about energy. To some extent, all these elements, they relate to energy. But may I say so that the problems in energy use, or I would say in irrational energy use, are not, the reason is not in energy, the reason is not technical. The reasons are more in the lifestyle, in user behavior, in political frameworks, in our understanding, and in the philosophy, if I dare to say so. And the principles of green building, if you read them on the right side of this slide, actually there is nothing new. We're spending now the 3rd consecutive day in your wonderful town, in wonderful Tbilisi, and we have seen your historical part of town, and we have seen your historical blocks with nice streets and courtyards and people who sit on balconies and communicate in a nice way. But then you can also find the environment which was built 50 or 100 years later and it is not working. So what is the reason for that? Probably some rules or some traditions that were very well known in the period of craftsmanship or in a this pre-massive design period. We simply forget these things and we think that we can do without them. We can make things faster. But as you probably know that fast product is a fast food. Fast food is not very good for your health. So we can say the same about the urban environment that you create. We'll go a little bit more in particular from general philosophical phrases into more particular aspects of green building, how is it described. So the first aspect is about urbanism. It's very much about the way of planning and design and of course the environmental and infrastructural basis for all that. So land use and ecology. Specific of a land plot. What does this mean? If developer does not think about the basic principles of the outcome of his intervention, of his development, he might get into a trap that obtaining a land plot which does not suit for the business idea or for the function that he has in his mind or he puts into his business plan, might put him into a very complicated situation when simply some functions and some volumes, they are simply not allowed and not possible in certain block. So starting to think about the idea at the very beginning, before you go to certain area, and having this in mind very carefully while selecting the site or the land plot for your intervention, it's critical. Use of ecological features, it's a well-known principle for planners and architects, but let me say so that in many cases, of course, good projects should not neglect environmental values of the site, but in many cases with a project, you can increase ecological value of the site by diminishing certain, by erasing certain layers that were acting against the specifics of the place, that were making pollution, by reducing amounts of hot pavements, for example, and giving more space to a green area and more space for public communication. If you look in time, there are, of course, long-term and intermediate-term and short-term effects that we plan with our projects. In most of cases, developers are interested in short-term effects and short-term outcomes, like realizing their project and putting it on the market and having successful sales. But if all types of stakeholders are involved into the process at the very beginning, they might also put the element like long and medium range effect and impact on the biodiversity on the agenda quite high, instead of forgetting it. Mobility is another sensitive system, and many countries have overcome the challenges of sacrificing our cities to cars. While educating transport engineers, there are some axioms that we try to deliver them to, and let me just mention some of them. Well, when we see traffic jams, we think that we should extend the streets. Yes, that's the first temptation. When we see lack of parking space, we think that we have to build new parking places. Yes, and we try to do that. But what's the outcome? When you build the new lanes for the streets, in the next 2-3 months they are full again. If you install a new parking space, in the next 2, 3 or 4 months it's full again. And not just like that. You get additional traffic flows, additional attraction of transport which never was there, because people see that it's more trendy, it's more attractive to drive there with a car. So probably it should work vice versa, and sustainable behavior would be completely different. Reducing attractiveness of driving is one of the challenges in modern urban setting if you want to create a better condition for citizens and for people. But of course, if you reduce the attractiveness of driving a private car, you should give something in return. So what could we give in return? This is of course the public transport, which should be not just functional, but also safe, attractive, affordable, and so on. You can continue the list. In addition, things like cycling and walking should be also very high on the agenda. You know, working with cycling, I've been speaking about this topic in very different countries, in the flat ones and in the hilly ones, and believe me, I've heard all the types of excuses why cycling is not possible in our country, starting with landscape and with habits of people and so on. And I can tell you one tricky situation. We were in mid-Sweden, in a town, in a city called Sundsvall, which is just down the fjords, and we were speaking about sustainable mobility system. And again, we had plenty of comments from local Swedish team. Then during the lunch break, we simply went on the street and we decided to make express interview with cyclists. And we said we will interview 10 people on the street and ask them, what are the basic challenges for cycling in Sundsvall? Among these, we selected people of different ages, and believe me, there were 3 or 4 very vulnerable age ladies. And when we asked them, what are the challenges, what do you need better in Sundsvall to continue cycling, and they all were cycling. None of them mentioned the terrain, none of them mentioned hill landscape. But finally, we were a little bit shocked with their answers, and we asked these ladies again, isn't it too big for you to cycle? And they were shocked. They said, why are you insulting us? It's easy. We are cycling, we're doing this every day. There's no problem, but we need more information, more signage, more safety, things like that. So all the soft measures are the basic things. If we may continue, this slide I would call the hardware. Time comes for hardware when we consider building materials. energy and water. I would like to start with the bottom line, and I think that water in town is a very basic element. If you look at the origin of most of cities, and probably Tbilisi is one more proof for that, that cities were starting and they were originating in the places where there was a water feature, good river, good water. And the places in Tbilisi which are now very attractive, they all have some access to water, or they might have better access to water. In Lithuania, we have plenty of water which is used for drinking, and we can get it from under the ground. We have deep underground water bores, so we don't drink from lakes. And somehow people are not very much attentive. We are not considering element like water. But if you look carefully in town, treating the wastewater and treating the rainwater, even the storm water, puts very heavy bills on the municipality. We spoke in Lithuania with people who are supervising building sites, and they said that we have 3 severe rainstorms during the year, and they are in June, July, and August. They are even very smart. They can even tell in the distance of 2-3 days when there will be a hard rain. But what happens then if you take the maximum flow of rain on a particular moment, which lasts between 5 and 15 minutes? Does that mean that we should design all rainwater system according to the maximum debit? We should end with this size of rain tubes. Is it a sustainable way to do things? And then what happens in the next days after the rain? If we discharge all the rainwater, then we have temperatures maybe not like here, not 30 degrees, but 20 degrees. We have to go and water our plants. And I have some pictures in Vilnius city when the cars are coming with water tanks and they are watering flowers and trees. Is it a sustainable way to do it? I don't think so. If we jump to building materials, well, I think after spending a couple of days in Tbilisi, I think that everything what you have in your old buildings is completely sustainable material because it's local. There is no long-range delivery. There was never a long-range delivery because it was delivered from the same region. It's natural. This means that it has a feature of self-regulating temperature and humidity, which is not possible with modern artificial materials. What happens next is a very interesting effect that it goes into our mind, like traditional material becomes architecturally fit to this environment, to this urban landscape. And then we treat it like something specific and very traditional to our place. So technical elements, they become conventional features of our architecture that we develop in this place. And therefore any other materials, how efficient they will be, they look very hostile to this environment. It's more tricky with modern materials. For example, if you go into public tender, you can obtain very cheap stones which are coming from China. They are more competitive to some materials that are produced in Ukraine, which was quite a regular source of supply of stone to Lithuania, for example, to Lithuanian construction market. But now China is offering better prices. Should we go for that? That's a big question. I think that we should think a little bit in longer ranges. Well, durability of material is a critical issue. If you don't put the regulations and set requirements during the public tenders in aspect of durability, you might get into the trap. I was telling an example, that example from our city that made repair one of the central streets in Vilnius, and there was a public tender, and the stone, natural stone, there was a proposal from China, which technically looked like the same. Formerly, it was paved with basalt stone that you have in Georgia, your wonderful basalt rock. It looked the same even, and all the technical guarantees were given, but after 3 years, these stones started falling apart. Well, they suffered 10 or 20 so-called frost cycles, freezing and melting, they started falling apart. So durability of these materials was very low. Well, now we have very high temptation to pave everything. We have plenty of proposals and we can make very nice drawings. I mean, we architects and designers. But more pavements we make, more natural surfaces are covered with artificial surfaces. There is less contact of soil to atmosphere, and there is less greenery around us. So probably we should also reverse this thinking and make the pavement just in the places that are really necessary. This is also including asphalt pavements. Energy conservation is also related to the building materials that we select for construction. Well, in energy aspect, the important thing is monitoring, just knowing how much and where do we spend. This might say, as some of experienced engineers say, this might save you 25–30%. Without any insulation of the envelope of the building, and without putting any sophisticated material, because you simply get the knowledge, you see where are your red points, you can reduce the peaks, and you can maybe think of some use during the low consumption periods that balance your use more equally. Well, even mobility system, if it's more efficient, it can also save lots of energy and lots of fuel, which is currently used for public transport systems, for example, and so on. By the way, yesterday in a workshop there was an interesting proposal about that some additive to the fuel. Maybe it's spoken also to the guys who have invented additive to fuel, which reduces the fuel consumption by 1/3. This is very interesting to mention. It deserves more technological and real-life testing. Well, we are speaking now very much about conserving energy in terms of making envelope insulation more and more efficient. I will return to this aspect later, but probably our goal, our final goal, is not to make the building as much airtight as possible. Not to put the building in a plastic shell. But the goal is, by our design and by all means, to facilitate the most efficient interaction with the environment, both in physical terms, like humidity, temperature, and also in aesthetical terms, like visual relation to the environment. This chapter might be called landscape because it's dealing with quite soft measures like health and well-being aspects, visual comfort, air quality, thermal comfort, water quality, acoustic comfort, safety and security issues are well known. But usually in the projects, what we do, sometimes they are at the very bottom, they are not emphasized with the client, with the developer, so somehow we're not so much focusing on these issues. Then is the chapter about the pollution. Green buildings should be really caring about the pollution that they make. And there are mainly two directions of possible pollution. Firstly, protecting from external pollution, and then preventing noise pollution from the buildings on the environment. Interesting topic about night lights. There was research done with street lamps about the way they put the light on the territory, and it was noticed that in most of cases, if the lighting system is not carefully designed, so from 30 to 50, even 60% of light goes on the areas which are not needed to live. So that also means overuse of energy. This means that we should not just put the lamps and forget the whole thing, but we should simulate and look what areas are really lit by these lamps. And by the way, there is also, speaking about the night light, there is clearly an architectural and urban dimension, which means that nowadays, especially with very wide application of LED devices which have fancy colors like orange, red, green and blue and whatever, we are slowly turning our cities into Disneyland, which has nothing in common with the historical townscape, where lamps in most of cases, they were fixed just to buildings and they were putting the light very functionally on the places that are really needed to be lit. These are what? These are entrances, these are staircases, main doors, and that's all. So if you look on a townscape like a value, like an architectural value, probably we should also carefully consider that. Next chapters of green building are waste, reducing construction waste and running waste, which are quite clear. Well, the interesting thing is that each of these aspects which I mentioned here, they are interconnected with the other aspects. For example, if we use natural materials which could be recycled or reused, so automatically we reduce the amount of waste that we have. Next aspect is process management. If you remember the first slides that I started my presentation with, about the different process organization. So the thing is that with conventional process organization, we cannot achieve nowadays, the high standards and high goals in construction. We need specific management systems and specific devices like BIM and participatory planning and simulation systems in order to be able to put all these stakeholders, not just on a nice slide, but also into a workable team, and to make it possible for everyone to make an impact on the project in a real time. So process management becomes a very important issue for achieving high standards in green building. Well, innovation is a very horizontal aspect which covers all of the above mentioned criteria, and it integrates all possible innovative solutions into the project in different phases of its realization. The thing which is coming the last, but probably it's one of the most important in order to make the thing work, is economics and profitability. And tools like life cycle costing put very good light on different versions of design. There is quite an easy software nowadays which allows us to test different versions of design, different alternatives, and look how different solutions, how they look and how the building, how it would behave in terms of life cycle cost. So the thing which is well known for economy professionals like cost-benefit analysis is not so frequent thing in a construction and in development phase, but especially in the projects that are related to long-term functioning, like, let's say, public institutions, governmental buildings, schools, kindergartens, and other facilities that are not just built and used at the moment, but they will be used and utilized for many decades. So probably a little bit more spending on the project and analysis and other simulation instruments might make huge winnings in the long term. For example, I can just mention one comparison that, one of the most complicated buildings are healthcare buildings, hospitals. Hospital equipment goes obsolete in 3-4 years. Is one thing. This means that we have to change the whole technology in the hospital in 3 years. This means that hospital is in a continuous project of refurbishment, redesigning, and construction. It is also true that the costs of running a hospital for 3 or 4 years are equal to the construction costs. So let me ask you, if we just think about the cost of construction, can we have a good hospital? Probably not. This is a slide showing that green building management is important in all the phases of the project. Pre-design, project design, and post-design. And for that, I used a slide from Japanese sustainability assessment system, CASB. You can access it on the internet for more particular information. And Japanese have already designed certain aspects for assessing quality of the project in different phases. I think that this is very good idea, which allows you to look how efficient and how good is your project before you get into the trap of construction, and then you realize some mistakes. These are the most expensive mistakes and most difficult ones to change. But already at the conceptual phase, you can see what are the possibilities and what are the opportunities in your project. How can you improve it? My good friend Pavle Zinzibadze has written a paper and has made a research about transformation of urban space in historic districts of old Tbilisi. And of course, when we look on legacy, usually we say that, okay, that's very nice, that's fantastic, let's have it like this, but in all particular situations, it's very difficult. You need to find exact solutions and to give ready prescriptions, what should you do? But of course, the main thing would be to figure out what are the basic values. As Pavle said yesterday evening, he said, sometimes while we are discussing about the strategies and policies, the buildings already collapse. So we should also take into account the aspect of time. Because time is here and the problem is now here today, and we should find the solutions. Of course, there is a temptation to pull everything down and to rebuild the picture with modern materials. With concrete slabs, concrete blocks, put polystyrene on walls, and maybe, if you like, we can make exterior decorated like it was. But probably it's not the authentic thing. So finding the best solution is, of course, the question for every particular project and design team for every city. The thing what I'm sure in is that you can obtain the best result if you invite all the stakeholders at the very preliminary phase and try to be very constructive and have to organize very efficient dialogue with your people where everyone would contribute his expertise and his knowledge from the field at the very beginning to set the efficient strategy and implementation plan. Just some remarks about bioclimatic design. This is a very interesting aspect, and of course I'm not going to give you a lecture, you're not the students, but the thing is that as an architect I'm always interested in a way how good design could reduce the amount of devices and appliances that are needed in the project. For example, if we could have natural ventilation, why should we need air conditioning and complicated ventilation systems which cost money, they require supervision, maintenance, and if not, then they can damage your health. So for this reason we went into this topic and we are carefully analyzing how quality of the project would match with the environment and the surrounding aspects. The first important thing in bioclimatic design is managing solar radiation. Solar radiation control is a topic which is sensitive in all the countries. You can see the map on the left side where different climatic regions are shown depending on the amount of solar radiation that you get. But during the design process, if you could simulate, and really there is a very easy and not very sophisticated software which would simulate solar gains to your project. And, the interesting thing is that also the reflected radiation from the surrounding buildings has an impact. So locating the building and having the urban setting of the whole district, of the whole block, might also make an impact. It's not just sun rays that go through the window. I was reading that some of your towns in Georgia, they were designed very carefully, having in mind sun radiation. How the sun is coming up and how is it setting down. For example, having orientation along the north and south line would allow you to get the protection from hot southern sun and have enough daylight in the evening and in the morning. The other interesting thing is that landscape, which we usually think like a decoration, with very rare exceptions, architects think about landscape like a decoration. When you have some empty places in your project, you can decorate it. Put green burdens. Landscape could also work as a feature which is helping to regulate sun radiation, especially for this reason. You can see the slide with different angle of sun in winter and in summertime, and also different effect on the plant which is standing nearby. Next aspect, heating and cooling control. Heat losses, we know that very well. And basic goals are reducing infiltration loss, which means a tightness of the envelope, and transmission costs. We're doing this quite well in the modern construction, but the problems occur when you lose the overall balance. For example, making the envelope of the building too much airtight, for example, as required by a vessel cross system, requires plenty of technical appliances to keep fresh air on a needed quality inside the spaces. So, of course, we were mocking that in Soviet times, there was such a mock-up that windows were very bad quality, and therefore they had cavities, and this was a sort of ventilation. This was a funny feature, of course, but to some extent, every envelope has certain infiltration, and if you can provide natural ventilation, so in many cases, artificial systems are simply not needed. Of course, the climatic zone of the country and the climatic zone of the project has a very important impact. And the interesting thing is that, for example, in in my slides when I speak about Lithuania, I have some cases how to make the building more insulated, that no heat losses could appear in a cold climate. But if you go with the same slides to Spain, for example, to southern Spain, they have almost the same thing, because in summertime they have to protect from heat, from overheating. And what we notice with historic buildings, usually historic buildings were built with solid mass. That means that their thermal mass was very big. And if you take the changes of temperature during the day, during the whole day, thermal mass was acquiring heat during the daytime and it was losing heat at night time. So there was plenty of self-regulation in these processes. Modern buildings have very low thermal mass in most of the cases because materials that we like are very lightweight, and sometimes we enjoy that we have lightweight, but then the thermal inertia is very low and we suffer all the bad consequences of that. Even the roof materials. If you take the tiles that you use so frequently in Georgia, and we also use them in Lithuania, because they are very good. They are a little bit more expensive than the metal roof, but they last much longer, and if you recalculate their life cycle cost, it's much more efficient to use natural tiles than metal roof in many cases. But the metal roof could cause you plenty of heating and overheating problems. They need additional insulation materials under the roof and so on. Internal gains, this aspect is very frequently omitted in general. We have plenty of internal gains with different types of appliances in the buildings, especially if you look in a modern interior, we have plenty of devices. If we calculate this row, we have plenty of equipment here, which is delivering lots of internal gains, and also people. We should also carefully mind that. So the goals are reduce light gains and manage casual gains. And the most interesting thing is about natural ventilation. There's plenty of speculation about this topic. For example, if you want to achieve high energy efficiency, now it's believed all well around that you should install heat exchangers. All this is an additional appliance and it also is energy consuming thing. But if you carefully consider the psychological cooling, applying natural ventilation, air cooling and envelope cooling, you might avoid that with very simple and I would say very traditional solutions. For example, we know that in, I don't know about Georgia, but for example in Spain, they were, in addition to natural ventilation, they were always using water vessels. In the ground floor, they were installing a little water basin which allowed water evaporate, and in this way it was adding humidity and cooling the room space. And then having the vertical shaft across the building, this is a very conventional way of making houses in Spain and even in some North African countries, which don't have any of these sophisticated equipments. A couple of words about landscape, which is a very important topic in architectural design, but in most of cases we treat it like decoration, landscape like decoration. I will omit the topic which is very wide about impact of landscape on urban development in general. And one of the most modern urban theorists is saying that you should start urban development, planning urban development or redevelopment from landscape, not vice versa. Just a brief example. In January we have been visiting London and looking at one of the best BREEAM and LEED certified buildings in London. And then we asked some developer who was, if I remember well, it was Argent, one of the biggest developers in London. And we asked them, how do you start developing all this thing? Because they took us to their office and they showed a very lovely model, like half of this table. And they told us, we start with the park. We said, are you joking? No. They said, first you build the park, and then the people come by themselves. We don't need even to make an advertisement. Because we make a park in the place, and then people just come to the place because they already see the park. Sometimes it happens vice versa in Lithuania. If you look at the advertisements of new apartments and new offices, there's plenty of speculation in landscape. Different green parks and flower beds and even the lakes and mountains and so on. But sometimes they remain just on advertisements. They never come to life. So probably reconsidering landscape also is a very important element in terms of bioclimatic design, and the element that might have also impact on energy consumption of the building. For example, the criteria like aerodynamics around the buildings. I think it's a very sensitive issue in Georgia. Lithuania is a more plain country. We don't have hills and mountains. But even with organizing the groups of plants, you can create aerodynamic tunnels or tubes, or you can block them. So which is one more layer of knowledge which is needed for landscape designers, people who we believe are just decorating our projects. Then on the right side you see another feature which is very attractive design, but it's nothing else than a stormwater collecting device as well. I have a couple of case studies. We don't have very many good complexes, good green buildings, especially certified ones, but there are some projects and some buildings that are good in one or another way. So let me just show you an example of Grand Spa complex, which is built by a private investor in Urbanism. It is a resort town in Lithuania, about 100 kilometers from Vilnius. The private investor acquired the whole bunch of buildings which are on the middle slide. There is a hotel, there are 2 blocks of hotel, there is a conference center, there is a health center, water park, and apartment block. The engineers, the company which is named below, Baltic joint stock company, they were invited when the project was already in the middle of execution. They were simply asked to install a monitoring system. But the whole work of this company went much further, and what they did, they made a micro smart grid. Of course, this is not a real smart grid system, where they just they monitor, and what they noticed, what they realized, they noticed that there are plenty of surplus energy in different blocks, which is simply discharged to the atmosphere. For example, the swimming pool under its dome has plenty of warm air, which is needed to ventilate. So where does it go? It goes outside, ventilating the sky. In addition to that, the engineers proposed using the heat exchanger, taking the heat from this ventilated dome and putting it to the hotel block and warming up the inflow air in the ventilation system and delivering the air into the room, which has the temperature not 12 degrees but 18 degrees. This reduced the overall need of heating in the batteries, and in such a way they also used warm water which was heat exchanged from sewage pipes. The sewage which was going from the building, from toilets, it had a temperature of around 15 degrees Celsius. And with the heat exchanging device, they warmed the coming drinking water to certain temperature, and then they put this warmer drinking water into the floor heating system. And then the floor was a little bit warmer, the air was a little bit warmer, so the batteries needed just 50% lower. In such a way, they are saving plenty of energy and just exchanging resources between different blocks. So this is a sort of a smart block system. By the way, in a couple of days we are just presenting an application for Horizon project demand response in blocks of buildings, which is going to implement exactly the same system of partners in Vilnius and in another European city. So overall primary energy need is 74 kilowatts per annum, and this is quite a small amount compared to the other neighboring buildings. A return on investment of this project, which was funded by a private investor, and as my colleague engineer told, it took really a while to persuade the head of the company that it's really well doing this thing. In addition, I just mentioned they have already geothermal or soil heating, the whole soil heating field, which allows them to acquire around 95% of energy which is needed for heating. They are also connected to the heating grid in town, but they are just simply using very little amount. So return on investment is from 7 to 9 years, but because of the changes in fuel prices, It's around 7 years already. Now we have the 6 years have passed. So you can imagine that in terms as a business model, it is very successful. Some examples from other European countries. One water management office built in the Netherlands was employing the ground insulation from the southern side and protecting the building from overheating, and then using the natural ventilation in terms of the cool air coming from the waterfront. And also they were implying the heated and cooled slabs, the structural heating and cooling. You can see these arrows coming up and down, cooling in the ceiling, which reduces the temperature in the room, and for this reason you can avoid installing the HVAC system. Interesting example in UK, in Wales, UK, historical buildings are one more sphere. You know, sometimes we think that we can only do this green building with new buildings, and to some extent that's right. It's much more complicated to do with historic buildings. But I was shocked when we had a visitor, we were inviting the lecturer to our vocational training program for architects and engineers, and we invited a guy from Italy, from northern Italy region, and he showed us specifically activities of Italian architects and engineers in the historical buildings. Can you imagine a building from the 16th century which is certified LEED excellent? I was shocked by that. So what they have done, they have adjusted LEED certification system to historical buildings and implied lots of technologies, lots of small requirements how to gain more and more quality in the historical buildings. And as this lecturer said, the most important thing is not to harm the historical building, which is already sustainable by itself. To be very careful with cement-based technologies, be very careful with artificial, not permeable, not breathing materials, and maybe their gains in energy were not so high, but they get very high, very good points in terms of materials, in terms of microclimate, in terms of transport, and other aspects. University buildings, in the United States, for example, university buildings are the best examples to demonstrate sustainability and green building. It's already the trend and the fashion, I would say, that universities compete who will do the best university building. Because university blocks, they are working like living labs. You can take your students to the building and show things, not in a textbook and not in the slides, but you can really show the working building and you can monitor. And I think this is a perfect example which we have to learn. One more complex, I'm sorry for pictures, you probably cannot see them well. The thing with this project was very careful consideration of daylight and glazed facades. Well, most of the modern buildings, architects speculate quite a lot with glazed facades, but they do that until you simulate energy losses and energy behavior of the building, and you let them see the outcomes during the design phase. And if you can, using this simulation system, if you can change the amount of windows, and immediately, on the same moment, you can see the changes in your energy costs. So I think this is the way to train architects to think more rationally and more logically, and I would say look a little bit more from a functional and even a traditional point of view on the building, not just making glazed boxes like it happens very frequently. Some words about stormwater management. This is in brief the system how it works with rainwater, stormwater, even the place like parking. What can we do with the rainwater management on the parking? When you have big paved surfaces, you have a huge amount of water leakage during the rainstorm. You can always install a little channel as a swale, put some plants that like to grow in wetlands, and you can obtain this nice view. You continue your swales, you simply connect them to bigger channels that again you continue and you bring them to ponds, and ponds overflow into the river and wherever they need to go. So in such a way you gain, in terms of landscape design, you get more green space in town, and you don't need to come and water it every day because they have already some natural resource. And then the most interesting thing is that the soil is acting like a sponge, like an ecological sponge. It conserves and it keeps the water for longer periods when there is no rain. These are the pictures, the examples. This thing is extremely interesting. It's just a little switch in brain that can change the whole thing. Instead of putting the rainwater in the drain, you can redirect it into the green area and then you have it working. Just a very little thing to do. Yeah, wet ponds and dry ponds. And this is not a theory. If you go to Malmö, for example, so the whole Newport district is already built like this, not just in terms of water management, but also there are plenty of sustainable buildings and energy grids which are working already there in practice. One project in Lithuania, nearby Vilnius, we had developed quite a big urban area with some existing buildings and very diverse community, meaning local residents and companies that own some land plots and private people which had their small land plots. But it turned out, they started doing the design project, made the planning, and they realized that the amount of rainwater that they obtain, they need huge infrastructure for that. To design it according to the conventional way, that means to discharge it to the tube and to bring it to the cleaning equipment. This infrastructure was like around 50% of the whole cost of the project. This means that they should forget it. But then they started looking on another ways how to work with rainwater, and they figured out the system. And on the right hand side, you can see the way how they designed the whole master plan of this district. When the water was maintained in the area where it appears, they obtained plenty of ponds, local ponds, and in terms of real estate, I think you all have seen that when you have some water feature, it's very attractive for people. People like such areas because they are very recreational, they have very good microclimate. So the beginning of this project is very successful, but there was a problem for our ministry and for our environmental agency to get this project approved because we didn't have this rainwater management system in our code, in our building code. So the private investor was going to the ministry and telling, look, there is such a thing, and well, let's do it. Of course, the ministry could not refuse it. So this is the way how building codes and different types of regulation, they are also upgraded when people who are inventive, who know, by the way, not an innovative model, who can apply very traditional technologies in modern setting where they can improve also the national regulation. But of course, the first ones, they are suffering most of all. Finally, just a few words about Green Building Council. I found in internet that we also have such an organization. In Lithuania, we have established the Green Building Council, which is a branch of Green Building Council functioning in more than 100 countries around the world. We have established our council in 2013. Now we have around 20 members in our association. And the interesting thing is that our members, they come from all different spheres. It's not a professional association based on the profile of the company, but they are coming from different sides of the construction process. We have launched the training program, vocational education and training program for professionals. In the group, we have around 50% are architects, and then there are engineers, some people come from building materials companies, and some are from real estate developers. We are constantly following what is happening with our legislation and the code, bring some requirements and some changes to the ministry, and honestly now we have quite good contact with the minister. And what we have done during 2014, we have worked out the green building certification system. So this is the map of our members, which represent different spheres of construction process, and we try to keep the balance that none of the groups is taking the majority. Well, during our vocational training program, of course everyone has the university training degrees, but honestly, even nowadays, in architecture and engineering programs, there is plenty of things that we should improve in this context. And the first thing is to put students of different professions closer together, that engineers and architects, they could realize that there are colleagues who are doing the same work, but a little bit in a different way. When they start working in practice. These are the titles of the courses. They all cover some specific areas of competence. Yes, and these are some lecturers that we have invited from different countries across Europe. We know who is the best specialist in what field to get some information. Actually, we are executing this program together with our Latvian and Estonian colleagues regionally, and the lecturers, when they come, they travel through 3 capitals of our region. And now a couple of words about the regulation and green building assessment. You know, we can speak quite a lot, but then the moment comes when we have to say which building is more green or more sustainable than the other. That means that we need some ruler. We need to compare and evaluate. The technical regulation is just the very bottom line, which is allowed and which is possible in the country. So I call this like it's a floor level. Technical regulation is our floor level. But there is something else. We should not do everything on the lowest allowed standard. And this is a green building assessment system. Green LEED, the GNB, and our Lithuanian national system, which is higher than the technically allowed regulation. And the interesting thing that also these green building assessment systems, they also make the technical regulation standards raise up and evolve and develop. There is another level, even higher one level, I call it the dreams level. Those of you who are not acquainted with Living Building Challenge system, it's an American developed system in northwestern region of America and Canada. Please look on internet, you can really find very attractive things in the system which considers the building not like amount of building material, like something hard and stuff, but they consider the building like a living structure, similar to the nature, which is changing, which is growing, which is declining. So for this reason, green building system, assessment systems, they are needed. And the interesting thing is that they all are voluntary. In all countries where they function, they are mostly, in all cases, voluntary. Imagine a real estate developer who is doing a building based on a technical regulation level. So he's on the bottom one. But if there is a competitor who is doing it on a green building level and brings the thing to the market, which is economically sustainable, so of course he has a better situation, because if you can demonstrate to the client that you're building, let's say your apartment house, in long term it is more efficient, it's more healthy, it has positive effect on user, it increases efficiency, work efficiency inside. So this product is more attractive on the market. And then probably in next years, the amount of developers who are doing buildings based on the lowest level is decreasing. So this is the trend, and this is the impact what green building assessment systems are doing on the construction market. There are different assessment systems, many of them, you all know them, they are green LEED, and German system which was established just 8 years ago. The specific feature of DGNB is that they have very good economic sustainability tool, LCC, life cycle costing engine. But there are also national systems, and I think this is understandable because in business we have national developers and we have international companies that are moving around the continents. So in Lithuania we were 2 years ago, we were thinking, what should we do? Should we take over green LEED or the GNB systems, which they are very good, they are smart, and we had different proposals for these companies. By the way, they all are private companies. To give some aid to us to come with training programs, but then we thought, what happens if we have different type of developer? If we have green in Lithuania, promoted all over, and if there is someone coming with LEED or GNB, happens then. So it's more tricky for our engineers and architects to learn one system, then you are not able to work with another one. But still there are some similarities between these systems. I think about 80% of requirements are similar. And then we looked on the example of our neighboring countries like Sweden, which also has its national scheme. By the way, Swedish national scheme is I love it very much because you can print it out, it's all on one A3 page. All system on one page. all the indicators, everything is described there. So it's very simple and very clear to understand. We decided to develop a national green building certification scheme in Lithuania, but of course we also appreciate if someone is coming and doing building by excuse me, green or LEED. This is the structure of our assessment system. Actually, we have covered all the main chapters from international schemes, starting with energy until the project management. What we have skipped a bit of bureaucracy, honestly, and we have skipped some criteria which are not of primary importance for Lithuania at the current moment. This is the overall list of criteria. There are 29 criteria and their weights, as you can see. Energy has a lion's share, we can say, then transport and water, transport and materials, and the rest aspects have from 12 to 6% of the overall weighting. So what we plan to do next, we plan to launch a competition for green buildings starting with September. Of course, we will not have buildings that were designed and built according to the system. So probably we will make a competition and we will award the participants in different categories. Someone who is the best in materials, the best in energy, or the best in health and well-being. But we hope that in 2-3 years, when the thing will roll up, we will have proposals and the designers and the companies working on the whole too. So overall goal of assessment system is not to tell how bad or good is your project, but the goal is to show you the roadmap and to show you how you can achieve good results. You can do your assessment or you don't do the assessment, but you could know that this is the way, these are the criteria, and these are the ways to do it. Of course, each of these criteria has very detailed description. What for are you awarded the criteria, the points, the credits. We also thought that it should be very transparent, so all the criteria are mostly presented in quantitative way, which is easy to evaluate and human factor is minimized. Also, people who are taking part in our training system, they will be the first evaluators. Also, everyone who has BREEAM or LEED or GMB certificate as assessor also might be the one who joins the team for evaluation. So we start with evaluating commercial and residential buildings, just the new buildings at the beginning, because it's a little bit easier to start with, and then we can also go to existing and renovated buildings in next phases. For the end, I have just a couple of last slides about the benefits. This is not my research, this is done by very powerful and rich institutions like World Bank and IFC, it's World International Financial Corporation, which is a branch company of the World Bank, and they have done the assessment of green buildings over the world that were built in a period of 7 years. And they have noticed, it's very interesting in architectural point of view, you can see that the buildings which can be called normal buildings, which are not so high and not skyscrapers and not especially built to shock the public. The additional costs are very moderate. It's from 2 to 4%. But of course, if you want to build an outstanding building and make it very high, like beat the world record in the number of meters, so then you should pay a bit more. And then there is a slide which is showing also the benefits of green buildings in terms of efficiency for productiveness, for the health of users, for savings of certain systems, and so on. So I think this is very inspiring information, which puts a very clear question for the developer: would you like to do the thing in the way that you have been doing it for ages, or would you like to go in something more advanced and more sustainable? So thank you for your attention. I would welcome your questions.